I'm going to talk about some stuff that, who was in this room for the first session for Marcus's talk? Okay, a couple people. So this talk will build a little bit on what Marcus's talk. He did a talk about what ESBs would look like today, and we'll talk a little bit about that. But it's going to be more focused on what's important about continuous delivery, continuous integration, how integration technology fits in, and specifically we'll be talking about JBoss Fuse and OpenShift and how OpenShift enables that sort of philosophy. Who's heard of OpenShift? Yay. Who's heard of JBoss Fuse? All right. Awesome. Okay, so let's get started. My name is Christian. I work for Red Hat. I am in a middleware specialist group, an architecture group, strategic architecture. And so what I do right now is I go on site and work with clients to implement their integration strategy and a cloud strategy and a microservice strategy and all this stuff. I do that sort of in a pre-sales role right now. So I just joined this group about a year ago now. But before that, I was a consultant. So I would be on site for weeks at a time, actually hands-on code and building the stuff up from architecture down to the deepest levels of the code. I'm a committer on ActiveMQ and Camel and contribute to Fabricate and other various open source projects. And I like to talk about distributed systems, cloud, microservice, all this stuff. And I do a lot of blogging, sort of proving out thoughts and generating ideas and that kind of thing. But what we're going to talk about today is what's the current state of business that's really driving a lot of some of the hype stuff that we're talking about today, and why, in my opinion, you got to keep that in the forefront. As developers, architects, or whatever, business analysts, you got to keep these things in your mind, and we'll talk about what those are. We'll do a little bit about what JBoss Fuse is specifically, and how it's different from traditional, maybe big vendor integration technology. And then we'll introduce OpenShift and what OpenShift brings to the table and how it solves some of the problems that we'll talk about first. The whole culmination of all of these things should end in a successful continuous delivery demo. So we'll see how that really goes. Okay. As developers and architects and technologists, we're really interested in new technology, new methodology, trying out new things. We kind of reinvent the wheel sometimes. Some of the things we talk about today as far as distributed systems have been described for the last 40 years ago or 50 years ago. But that's all good and well. And we're developers, we like doing that kind of thing. But the business, your employers, they have specific reason for why you're doing your development. They're there to make money. They're there to make money or save money, and if they make money, they want to make more money. So how do we tie what the business wants and what helps generate money to what our role is in IT? And when we start to look at the details of how we allow the business to be, quote unquote, agile, to be able to respond to market conditions. Because these companies are, even if they're really big companies right now, making a ton of money, maybe if you're Walmart or something, you're making a ton of money, there's always that risk of competition, there's always that risk of startups coming and stealing your market, and regardless of what business that you're in, technology is probably making a bigger and bigger impact. It's probably the smart companies are using technology to make their solutions their offerings differentiators based on the technology that they're able to use. So for example, I just saw an article that Disney, if you go to Disney World, you sign up, you buy your tickets online, and then they send you a wristband. And this wristband isn't just a paper wristband, it has an RFID sensor in it. And when you sign up, you can click all the rides and the attractions and stuff that you're interested in, and they'll come up with an optimized map for you. When you enter the park, that little RFID wristband now knows you're there. It can send you updates to your phone. Hey, this ride over here has a wait time of 20 minutes. Most popular ride, you can go over there. Or if you want to optimize route for where you are, based on distance and based on wait times. And then you can order food from your phone and then walk right into the restaurant, and they'll greet you by name because they know who you are and that you're coming and that you're there. And they'll bring your food out. You don't have, they find you. So that's one use case, but you guys, each one of you could probably come up with all kinds of other interesting ways that the business right now is trying to differentiate itself. And more is realizing that technology and that IT is a fundamental part of the business. That's what enables some of this differentiation. It's not a cost center. It's not draining. Some companies still look at IT as, hey, you guys are sucking my budget. But the smart ones and the ones that are going to stay around are adopting, embracing technology fully, and using that technology to come up with this new innovative stuff. But how do you have a company that is making, let's say they're making a ton of money right now, they don't want to screw something up either. They don't want to be too risky with how they do that. So for the business to be agile, for the business to adopt and to change, we have to identify areas that are roadblocks or barriers for how the business wants to change. What are those areas? If you stop and think for a second about all of the areas, everything that you have to do to deliver a solution from inception to production, and stop and think about all the steps you have to take, and you're conscious about where the inefficiencies are and where those roadblocks are, and where you're really paying the price for having to for doing this sort of development and introducing new software, changing existing software. In terms of development, you can identify it pretty easily. When you have to change your code, how do you know that what you did change didn't break other things? How do you know what you introduced was what you intended to introduce and not some bugs or whatever, right? So on the development side, and I can't stress this enough, and this is not new information. I'm sure you guys all heard this, but I still go into clients, and when I say this, it's like the first time they've heard it, or maybe they have heard it, but they do it half-assed. But that's testing, unit testing. Follow whatever, test-driven development, whatever you want to do, but you need to have different layers of testing, but start off, at least have unit tests. So when you make changes to your code base, you're not breaking things. Now, if you start breaking things, that's going to slow you down. That's going to be a huge cost. So when you start promoting these things to development and to QA and UAT and production, you start introducing bugs and regressions and stuff. That's a huge cost to business. So from the development perspective, getting that feedback early and maintaining those, take seriously continuous integration, take seriously your testing, because these are things that will impact the business's ability to make change and for you to make change. So that's one layer. I mean, like I said, take a moment and think about what's in your operating environments also that prohibit or incur a cost for change. So operationally, when we have maybe if you're going to deploy your application to QA, oftentimes you have to coordinate with other teams, with the operations or the build and release teams. All of this coordination, cross-functional coordination is it's cost. You have to synchronize. You have to figure out together, okay, what do you want me to do? Oh, you want to put your app on this server? Well, I have this other app over there. Now there's 3 apps on this server, and if I make some change to those applications, it could adversely affect all the other applications on that server. You got a lot of shared contention. You have contention points. For example, shared servers, shared application servers. Anytime you're having to coordinate with other teams, then you're introducing a level of cost that's going to slow you down. At the infrastructure level, I was at a client in Northern California last week that told me, and this isn't the first time I heard this, that for them to provision, or for them to start a new project, they had to go buy hardware resources. That for them to get physical servers was cheaper than getting virtual machines. I don't know how that makes sense, but that's not the first time I heard that either. And they also said that it takes them 3 weeks to get a virtual machine if they were going to go down that path. So not being able to, I mean, things that boggle my mind still that don't make any sense, but that's part of the cost. So how do you get an application into production? Well, you've got to start off by buying a rack of machines, installing it, installing the operating system, security, DNS, all that stuff that you have to manually do, and you have JIRA tickets and process and all this crap that slows you down. It's a cost of change. So, and then even at the business requirements level where the users, oftentimes they'll come and say, hey, change the application so it does this. And then you do it, and that's still not what they want. You know, the business users, sometimes they don't know what they want. They don't even know what they're asking. But if you ask them to explain what the problem is, then you guys work together to come up with the right solution. Because otherwise, you know, asking you to change a button and move it over here, but oh, that didn't fix what the original problem was, that's a cost of change. That's going to slow you down. So you have all of these different, and this is not specific to any one industry. This is not specific to any one IT group. This is felt in modern IT groups today. Do people agree, or is that nah? everybody's on AWS and happy. No, okay. Okay. Now there's some new movements. There's some new hype out there. If you haven't heard of microservices yet, then where have you been living? Microservices and DevOps and API management and all this stuff. But I think that it's definitely super hyped, and people get it's kind of fantasy in some ways that people talk about this stuff. But there's for these philosophies or these methodologies, I believe that there's legitimacy to them, and that they grew up not through. So, for example, microservices didn't grow up with or emerge because some committee got together with all the big vendors who want to make a ton of money and came up with microservices. In fact, the opposite happened. We came up with SOA, which is awesome service-oriented. Really, the principles behind it were, but then the actual implementations of it were crap. And what ended up happening is we started building applications and eschewing that WS star and SOAP and all that stuff, and let's just use HTTP. Let's simplify things. We're already building complicated systems. Let's not introduce other layers of complexity just for the sake of some committee from on high gave you the path to use SOA, some big SOA appliance or something. DevOps, same thing. That companies who wanted to be efficient and who were small and nimble, they wanted to get better and they wanted to get faster. They wanted to release more applications to production. They wanted the business to be able to react and compete. So they looked at how you create airplanes or how you create cars and the assembly line metaphor that they use there, and they try to build up a culture around, because it's not something you just walk into American Express and say, hey, we're going to do DevOps today. There's an entire culture that goes along with that mindset, and we can talk a little bit more about that. But the one thing that I see over and over and over, aside from all of these other costs of change is that integration, getting systems to talk to each other, is a big undefined area where you can incur significant cost of change. So what I mean by that is we have all of these, your company, your employer, they have all these systems, different vintages, Corba, mainframe, .NET, Java, mobile now, and Internet of Things and big data and all this stuff, that they have to get that stuff to work together. The business wants all of those. Ideally, the business would have all those systems incredibly coupled and tightly wound together, so that they were efficient and they were giving them the information that they need. But if you do that, then you don't have a very maintainable system. So being able to have a maintainable system that deals with and works with all of your existing investment, all the legacy or vintage technologies is hard. And then you throw in the fact that these are all distributed environments anyway. So yeah, we got different platforms, different protocols, XML and JSON and protocol buffers and Avro and all kinds of stuff. Timing, whether or not systems are up. So you could have you working on a system that has to talk to another system, but if system B is down, does that break you? It shouldn't. Communication, cross-team communications, talking with the DBAs, talking with the build and release folks. So integration is actually really expensive. So here's the product that I work on, and I believe is a suitable solution to some of these integration problems. So what we'll talk about next, JBoss Fuse, is trying to address the cost of integration and reducing that cost. And doing it in a manner that's different than what your traditional big vendor ESB would have you do. So JBoss Fuse, I wrote microservices on there because this is the approach that we take with Fuse is small, lightweight, independently deployable services. They happen to do integration, but they're services. And it perfectly, and has for the last 6 years, fit this model of what people are now calling microservices. And that technology, Fuse, which is a 100% open source product from Red Hat. And I say product because it's what we support through it. We give enterprise support for it. We do consulting with it, or for it, and training. But it's 100% open source. It's not this open core crap with proprietary licenses and all that. And it's based on very popular open source projects at Apache. Apache Camel, ActiveMQ, Fabricate, which we'll talk about. Well, Fabricate's not at Apache, but the majority of the stack is. And when I say it reduces that cost, that integration cost. I mean, IDC did a study. You don't have to take my word for it. IDC did a study of 6 of our customers, very household name customers, that adopted Fuse in place of the traditional old legacy ESB vendors. And their return on investment over 3 years, because they were able to integrate more applications with fewer resources and speed up integration, so reduce the cost of integration, they were able to get a return of investment of 488%. And that report, the IDC report, goes into exact, because when I saw that, I was like, what? That's marketing nonsense. But I went in there and it spells out all the details of how they calculated that number and how they came up, and it seems pretty legit. So, I mean, I've been using Fuse for a while, I've been doing Fuse for a while, and I've always thought this, but now there's industry analyst research that shows up. So Fuse is a, I don't want to call it an ESB, because that has connotations to the legacy ESB vendor. Fuse is more of the and has been doing this is more of the microservices approach, where you have individualized containers being able to deploy your integration services to them, remove them, update them, and they coordinate with each other in more of a choreographed interaction as opposed to orchestrated interactions. It doesn't have to be. You can do orchestration, you can do all that kind of stuff with Fuse, but its sweet spot is event-driven architectures and choreography. It's built on top of Apache Carafe, which is an Apache project, open source, that's built, and that itself is built on OSGI. It's an OSGI core. And the reason why they chose OSGI back in 2007 to go down this path is actually still very valid today. Everyone's talking about microservices and Spring Boot and Drop Wizard and Embedded Jetty and whatever. But none of those, so the assumption is that microservices have to be deployed independently and process isolated, which isn't the case. There will be times when you co-locate your services. But when you do that, and when you start to throw multiple services into a single JVM, how many of you have heard of class path collisions or class path issues or class not found exceptions? You end up getting multiple dependencies that conflict with each other, and the traditional Java, either Java EE or standalone class loader can't handle that. It doesn't have modularization at that layer. It's not enforced. So OSGI enforces that. OSGI enforces that modularization, and the class loading structure is not hierarchical. It's a graph. So even to this day, the OSGI container that we base our integration services on is a very powerful model for building out microservices. So inside that container, the type of services that we're going to build are with Camel, Apache Camel. And Apache Camel itself is a library that implements some features and some functionality for integrating systems together. And I'll talk about what that is. But I want to focus on that it's a library, just like Log4j is a library. Log4j is not tied to WebLogic or Tomcat. It's not tied to any container, and Camel is not tied to any container. For Fuse, we bundle it, and we prefer that you use that one for implementing your services, but it's just a library. And this library implements these enterprise integration patterns. Sure, there's a familiar book to all of you guys. There's an integration track here, so hopefully you guys have seen this before. But this book it describes a language for how we communicate with developers and with architects and with the business about what is being integrated. Not how, you don't care, I mean, they won't at that level, they won't care how that all comes together, but you need to be able to describe that. Reducing that communication barrier is also a reduction in the cost of your change. You have to be able to talk and coordinate and communicate exactly what you guys are doing. So it's an EIP. It has a very expressive domain-specific language for describing your integrations. Written in, there's a Scala one, there's a Java one, there's an XML one. So all these different DSLs, so you're not tied to one specific way of doing things or one specific user interface. Strong unit testing. So if we go back to the development cost of change, strong unit testing. Very, very easy to write a happy path integration from point A to point B, but what happens when things start to fail? Being able to inject exceptions, try out all kinds of negative path behavior without having to deploy into a container from your JUnit test is very powerful, and we should be doing that. Red Hat offers developer and design time tooling through JBoss Developer Studio, which is basically a set of Eclipse plugins that allow you to drag and drop the camel routes and deploy into a server with a drag and a drop. So there's a lot of tooling that's built around this as well. Everyone thinks that building out services, well, I shouldn't say everyone, but the prevailing wisdom seems to be that building out microservices or whatever is rooted in SOAP or REST. So SOAP's gone. Let's get rid of that. Let's just do everything as REST calls. For anybody that's built out a very complex system, or even a moderately complex, or whatever, you'll find out really quickly that once you start chaining together 10 and 15 and 20 calls, REST calls, or RPC calls, that you might end up somehow calling the original service that started that interaction. And so that is a very brittle runtime coupling that, I don't know if you guys saw Marcus's slide earlier about how Netflix has its microservices, and then there's just a huge web of services calling services, calling services, calling services. Amazon does the same thing, and I'm sure Netflix does this too. But on the Amazon side, I have some experience. There is that web, but there's also a very strong event-driven architecture that runs behind that. And being able to do pub sub, that's the runtime decoupling that you need to get to if you're really going to be able to change a service without affecting everybody else. And for pub sub or queuing or any of this asynchronous event-driven architectures, you can build out with messaging. And with Fuse, that's not very uncommon. We do that. Like I said, the event-driven architecture is the sweet spot for this type of complicated distributed system. And we use Apache ActiveMQ as the queuing mechanism for that. Now, once you start to deploy any set of non-trivial services, queuing, multiple nodes, clustering, and failover, and high availability, and all this stuff, once you start to get to these sort of non-trivial deployments, things get complex really quick. How do you manage configuration for all of that? How do you update configuration? How do you do service discovery? How do you do failover, load balancing, master election coordination type things? Clustering is difficult. And what Fabricate brings to the picture, and when we talk about JBoss Fuse, we talk about Fuse Fabric, which is from the Fabricate community. What Fabricate brings is a cluster management platform. What it does is allow you to simplify your deployments. So very analogous to how we already today use Puppet or Chef or Ansible or Salt or whatever to provision operating systems and VMs. Where, like for example, in Chef you have a recipe that describes the end state of your system. With Fabricate we have the same thing, we call it a profile. And a profile describes what the end state of a JVM deployment looks like. What jars need to be there, what configuration needs to be there, what dependencies exist. So when you describe that in a text file, not only can you version it and do diffs and do all that stuff, but now you can apply that profile or that configuration to the JVM, and now the JVM is going to go automatically provision itself. So like today, if you provision out with Puppet some rel-based server, it's going to go pull all the RPMs and stuff from a repository somewhere. And the same thing would happen here. We apply this profile, and all of those wars, jars, tiers, whatever, get pulled from a Maven repository. So this allows you to, from one central location, configure an entire cluster, fleet of servers with a couple of clicks. Because the Fuse or Fabricate is built on top of Git, so there's like I said, all these things, these profiles are text-based files. We store all of that stuff in Git, and you can do diffs and rollbacks and all kinds of stuff. You can use Git tooling outside of Fuse to edit the profiles. But we also get versioning built in, configuration management versioning, as well as being able to version your deployments from version 1 to version 2 to version 3. Oh, version 3 introduced a bug. We'll roll back with a couple of clicks to version 2. So it makes managing a fleet of servers a lot easier. All of the configuration is stored in one location and allows you to do smart service discovery. All of the JVMs that get created, all the web services, the SOAP or the REST services and the MQ services, all of those get populated into a runtime registry so that the clients within those clusters can automatically discover where the REST endpoints are, where the SOAP endpoints are. And in a static environment, that might not be as painful because you know where the VMs are and the IPs and ports and all that stuff, firewalls and all that. But if you start to move into a cloud environment or a PaaS or some sort of infrastructure as a service, you could have REST services coming up and going down, and being able to manage where things are currently and being able to find them and locate them at runtime is key, crucial. I mean, because you don't want to hard code all this stuff. So we talked about some of the inhibitors for change. We talked about integration kind of being expensive, and Fuse, I think, brings the right approach to dealing with that. But now, what about at the operations level? What about the interaction with the developers and the operations teams and the infrastructure? OpenShift aims to solve that. So OpenShift is Red Hat's platform as a service. It's like Heroku, or if you have some self-hosting services like that you can publish a PHP app or something to. Usually you publish the code to it, and then that PaaS takes care of building it or deploying it to the right container and restarting the container and all that. So that's what OpenShift brings. And when we'll see that Fuse, so running your integration services, your integration microservices on top of OpenShift, now gives you all the same benefits OpenShift brings you. So number one, to me, as a developer, it gives the developer the autonomy to go self-create his or her app without involving procurement and operations to get hardware in and operating systems and all this stuff. You go to a portal or dashboard, or you go from the command line if you want, and you click here, I'm going to create a new Node.js app. So it creates the Node.js runtime, creates a Linux container behind the scene, and now you push your code, your Node.js code to OpenShift, and then OpenShift will take care of deploying that code to Node.js. Same thing with JBoss Wildfly or EAP or Tomcat or Fuse. So what this does is allow developers to get started more quickly and to experiment more more quickly, to be able to prove out whether a technology will work for them or to get a solution going so that they can start to move it down the path to production. But there's a lot more that goes into getting an app from development to production usually. You're not just throwing it into production. And the PaaS, so it not only helps developers self-service, but we'll see, I pointed out the cost of, one of the costs of change on the operations side is these shared infrastructures and having to coordinate with everybody and possible collisions and all that. The PaaS, OpenShift, allows us now we don't have to have shared infrastructure. When we run our builds and our tests and make changes and all that stuff, we can spin up an entire fleet of applications on the fly and test that not only our application is correct, but that the environment got configured and set up properly, which is very almost impossible to do in a shared environment. Usually the operations teams are hand crafting the servers and the application servers that run on top of it, and you might have dependencies, RPM mismatches, and changes that you make might blow things up you didn't anticipate. So being able to test and configure your environment along with your code is powerful. So Red Hat is a completely open source company. We don't, like I said, we don't do the open core silliness. We're 100% open source. So in our model, OpenShift origin is, if you go to GitHub/OpenShift, OpenShift origin is our open source version of OpenShift. So you can go get it, go download the code. The next iteration of OpenShift is in progress right now, the version 3 of OpenShift, which should be announced in summertime. And that's built completely on Docker and Kubernetes and all the other developer PaaS stuff built on top of those. But today, the OpenShift 2 that I'll probably be talking about is still built on those same principles. OpenShift has been doing Linux containers for about 4 years now, so that's not new. The Docker stuff, the Docker images and all that stuff will be incorporated into OpenShift 3. But Red Hat's PaaS, OpenShift is still built on Linux containers, still built on container orchestration and smart routing and all that stuff. And if you downloaded OpenShift Origin in the community, it's Apache licensed. You can just build it and use it. We also have a hosted version or hosted option. If you go to OpenShift.com, you'll see that is a public-facing, very much like Heroku, where you go and you sign up. I think if you sign up, you get 3 free gears. We call gears, which are the Linux containers into which you can deploy your apps. But you get 3 free gears, and you can just, I think there's like 2.5 million or 3 million applications deployed on OpenShift online today. And it's hosted, it's provided as a service. Now, for the enterprise use, where you may not want to use a public-facing PaaS, maybe you want a private PaaS and self-host it, or maybe you host it on your own infrastructure as a service or whatever. It just has to run on RHEL. OpenShift doesn't care where it runs on, except it has to run on RHEL. It can run on bare metal, VMs, Amazon EC2, it doesn't matter. But for the enterprise, we have a 100% open source supported, enterprise supported version called OpenShift Enterprise. And this brings the ability to run your own private cloud. So your operations teams, now what they worry about, instead of coordinating with you and ending up being a bottleneck, now they focus on managing a fleet of servers not specific to any application or not specific to any type of use case necessarily. And that the developers, they manage and create their applications through the portal. And OpenShift provides that separation of concerns. If I, as a developer, go create a new Fuse application, it'll create one of these little Linux containers. You can think of it as a Docker container, and puts it on. It'll try to be smart about which host to put it on. But it'll coordinate getting those applications onto the right containers. If you set it up to be highly available, then if one container goes down, then it'll spin up another one for you. Now operations is out of the way, per se, for developers to get started with a POC or with their implementation and go forward. And the coordination that needs to happen is greatly reduced. Okay, so now we want to be agile. We want to be able to change. We know integration can be tough. We have Fuse. We kind of solved this infrastructure coordination stuff with OpenShift. But now how do you get an application from development into production? Going from environment to environment is a cost of change. If the environments are different for whatever little reason, or the configuration is different some way, then that's going to be undefined time that you need to figure out what the heck is going on there. What's the difference? What's the difference in those environments? So this philosophy, so it's a philosophy, right? It's not a team, it's not a book, it's not a product, it's a philosophy. DevOps is a philosophy. This philosophy that came out is about, from top to bottom, from CFO, CIO to janitor, everybody needs to adopt this idea that we are going to try to get our application, we're going to try to speed up. We're going to try to speed up from inception, when the business has an idea, to when that gets put in front of a customer. 18 months, 12 months, that's too long. We need to get those ideas out now because we need to see how the customers react. Because the business has this wonderful idea, but that doesn't mean that it's going to be profitable or save them money. It's sort of an educated guess, but they want to be able to test that theory. And the longer they have to wait, the more money they tie up in a project, the less return on investment they get. So DevOps is about getting that path from development, from the business on the development side into production so that the business can get that feedback from the customer, getting that path streamlined, removing roadblocks, improving communication, and getting that feedback at all steps, the development step, the operations step, and then ultimately the customers. That's what DevOps is. Specifically, continuous delivery is a discipline that employs this philosophy to make that pipeline real, to actually build out a system that you can check code in and have it pushed to production, or the doorstep of production. Maybe somebody else will actually push it into production. It's again, I can't understate how important testing is in this scenario, because the more we try to automate, the more we try to reduce these bottlenecks, the more we're going to have to rely on the automation. We have to have faith in that automation, and we have to have faith in those tests. That if it gets through the tests, then it really is ready for QA. Or if it gets through the QA tests, it really is ready for production. If we just start throwing nonsense tests in there, then there's no value in that. And your continuous delivery pipeline ends up incurring more bottlenecks because things break, things don't work. You're not going to continue to keep pushing bugs into production. You have to go back and try to figure out what went wrong. Continuous delivery philosophy is that every build is a potential release candidate. In practice, I've seen companies get to that every build is actually a release candidate, but in practice, it's more. There's a few more gates, I would call it, between development and production. That there's actually a human that checks to see, oh, is this really ready to go? Let's run your own manual test. So there is a little bit of manual testing still involved in practice, but potentially each build could go to production. So we try to automate everything, unit tests, integrations tests, acceptance tests, automate the infrastructure. We're implicitly testing the environment creation and all that stuff, so if it fails, we can recreate it. And in practice, here are some of the tools that I've seen used for this kind of pipeline. And these are the same tools. One second, what's the next slide? Okay. These are the same tools that we're going to use in our demo today. So using Puppet and Chef usually to provision infrastructure, provision virtual machines with operating systems and patches and supporting software. Git for all your source control and configuration. Everything that you can possibly get into a source control management system, get that. Garrett, who's heard of Garrett? A couple people. Garrett is a code review tool, and the purpose of that code review is to foster communication between the team members who are involved in that code base. What's changing? Why is it changing? Let's have a couple people get some eyes on that, and just so that they know and they understand what changes are being made. And of course, since Fabricate has its own level of automation for middleware, for Fuse, we can layer that on top of these other tools. I'm going to skip that. There's Maven plugins. There's all kinds of tools that come with Fuse to automate this sort of stuff. But so the sample flow, continuous delivery flow that we're going to look at is checking your code in. We're going to look at Garrett to do the code reviews. And we're going to have Jenkins automatically do a build to also give its input to Garrett. So that if the build fails, there's no point in doing human code reviews. So so Jenkins will vote in this code review process. And then if that all passes, then we're gonna, if it passes code review, then those changes will then be pushed into the master branch. So now your continuous integration can kick off. You can run a build, run unit tests. And by the way, Garrett, in that case, helps keep so one of the reasons why people do continuous integration really half-assed, or they start it and they're like, I don't want to do this anymore, is they end up with a lot of broken builds on their their master. And the number one rule is don't let the build break, or if it does, then fix it right away. With Garrett, you get these code reviews, you get the build to run sort of a pre-build to make sure that it actually builds. So now your master branch stays a lot more clean. It tends to be broken less. So then we can use, I just use Jenkins to build out the continuous delivery pipeline. There's a build pipeline plugin in Jenkins. And then we'll look at how Fabricate, so what we're really going to do is when we develop, or when we build our application, we're going to spin up a new environment in OpenShift and deploy our application to OpenShift. And then we'll run some acceptance tests against that environment. So we're spinning it up on the fly, and we're gonna we'll see this happen. And not every pipeline is going to be exactly the same. Not everybody's going to have a dev, QA, prod. People might have a user acceptance testing environment, or a prod mirror, or staging, or performance testing. So there's all kinds of variations of what the pipeline would look like. In our demo, what we're going to see is getting from on code, I'll commit it, go through Garrett, go through GitLab, go through Jenkins, and then get to OpenShift. And once it's in OpenShift and it's automatically deployed there and all that, you can migrate that to other installations of OpenShift and QA and prod and so forth. But the salient piece is getting that automated all the way up into your deployed environment. So here's what it'll look like. Here's what the demo would look like if it works. Because there's just a lot of moving pieces, and live demos tend to bring out the worst. We're going to commit to Garrett, go to it. If it passes code review, it'll get pushed to the master branch at GitLab, and then we'll kick off an initial build. All of the artifacts, all the configuration, all the stuff, all the fabric profiles, that'll go to Nexus or whatever, Artifactory, whatever you want to use. And then that will kick off an integration test. If it passes, it'll kick off an integration test phase, which will then kick off a deploy to OpenShift. And at that point, we'll spin up the environment in OpenShift, deploy the code to OpenShift. The next step should be an acceptance test. And that's where the demo will end. But like I said, depending on what your environment is, you can script moving it from one environment. If you get it working in one environment now, moving it in OpenShift, moving it to the next environment is trivial, minus the fact that you have to pay attention to the configuration changes, like URLs and passwords and all that stuff for different environments. But if you have it working, so it's the same idea as Docker. If it's working here, I should be able to take it and move it over here. Okay, let's see if that really works. Okay, so one thing I want to point out is here's so I purposely wrote the demo to be as automated as possible to spin up and set up. So all of the pieces, here I have that same picture here, all of the pieces are implemented as Docker containers and Docker images. So you would be able to go to this GitHub repo and see exactly how I set it up. There's no hidden magic. It's all scripted, like I said, to the extent that it can be, and all of these components, Garrett, GitLab, Nexus, Jenkins, are all deployed in Docker containers. If I go down here, how to consume this project, I can set up the demo yourself, and there's some scripts to create the Docker images and all that stuff, but it'll tell you how to set up each piece and run the demo. So what we're going to look at first is here's OpenShift. Okay, so here's our OpenShift portal. If I click on create a new application, I can choose from these different types of technologies that I want to base my application on. You can see Python and Ruby, and should be Node.js somewhere. Yeah. But we're not going to create an application. So this is if I was a developer, that's what I would do. I'll go to this portal and create an application and start building stuff, push code to it, have it build and all that. But we're looking at the other aspect, how do you operationalize a continuous delivery pipeline. And so I'm not going to create any applications right now. We're going to let the build environment, the continuous delivery pipeline, do that as it progresses. Here is our Jenkins. we have a set of build jobs. These build jobs are linked together. So if I look at the initial build, if I come down here, this should kick off. They're linked by the trigger, parameterized trigger. That's another Jenkins plugin. That'll just kick off the next phase of the build. So we're going to start off with the integration, or the initial build, sort of the CI build, and then that'll kick off the integration tests. And if that succeeds, that'll kick off the OpenShift, spinning up OpenShift, spinning up Fuse on top of that, deploying all that. So let's try from the developer's point of view. I would come here. I have a sample Fuse application. Okay, so it's a Maven project, a Java project that builds. That in this case, it's gonna build an application that exposes a REST endpoint. So I'm going to make a change here. I'm just gonna. So the purpose of this is really just to show that, hey, I'm gonna make a change and then commit it, and then we'll see the build pipeline. I'm not trying to be exotic with my changes here, so I'll just change that. And then I'm going to do a git add. And now when I do a git push, git push origin. What I'm going to do is I'm going to push this change to a special branch that Garrett knows about. Okay. Now you can. There's a plugin for Git called. What the hell is it called? There's a plugin that'll automatically do this for you, so you don't have to know the details. But this is the special branch that Garrett calls refs for mess. I don't know if you guys can see that very well, but so I'm going to do this push, and what this is going to do is create a new change set in Garrett that will kick off a build in Jenkins, and Jenkins, if it fails, Jenkins will vote -1 to this change. If it succeeds, Jenkins will vote +1. And then somebody else will come in and do a manual review and all that. So, did I misspell something? Am I not on the internet? I have to be. Add it on my phone. Damn it. Well, that didn't work out. The git push. I knew that this is a tricky demo. Okay. Well, we'll skip the code review part. So let's say the code review happened, and we got here. Where's GitLab? I'm gonna print the location of all of our stuff. So here's those Docker images running on a remote server out there at GitLab. So if we look in GitLab, we can see, here's our Fuse Quick Start. Here's the file. So it exists in the code repository, but I wasn't able to push my change for some odd reason. It being a live demo, probably. So let's say the code review passed, and our code got pushed into the master branch of the GitLab repo. What would happen is that this would kick off the CI build. This would kick off the initial step in our pipeline. So if I click on build, we should see down here that this is going to start to build let's look at the console. This is going to start to build the project, right? And then if it's successful, it'll push it into Nexus, and then let's find the Nexus. So here's our Nexus. Where's this thing? This thing succeeded. This was build number 4. You can see right here. So if I look in Nexus, I should see in our releases, there's going to be a couple of the previous builds that I knew worked before the demo, but then I try it here. So 1.04 is the one that just got built, so it got pushed into Nexus correctly. If I come back here, click on Jenkins, I can click on this little pipeline tab right here, and this will take me to the running pipeline. So again, this is the build pipeline plugin for Jenkins. And now this is the one that's, so we've gotten past integration tests. Now we're currently going to deploy to dev. We're going to push to dev, and it's going to spin up the Fuse environment. If we go back to OpenShift, we had no applications before, and we see that Fuse 104 got created. Now what that means is what we're doing is we're spinning up Fuse, and then we're going to spin up another container into which we're going to deploy this REST application using Fuse's profile mechanism that I talked about. And click on that. Console output, I should see, okay, well it's still creating the application, the OSC environment that I've spun up for this demo is kind of crappy environment, but so it might take a second, but once it creates that, then it'll create the profiles that need to go into the Fuse environment, and then it will create the new container and deploy the profile, which will pull that artifact from Nexus, pull this artifact from Nexus, and install it into a running JVM. Then you can run acceptance tests and all that stuff. And this guy is still working. We'll give it one more second. There you go, now it started. Now we're going to build the profile. So like I said, Fabricate has Maven plugins that will automatically generate these profiles for you. And once it creates that, it's going to push the profiles into Maven. So those are versioned, and their artifacts are stored. And then it'll pull those profiles down into Fuse and apply them to a running JVM. Okay, now we're creating the profiles, and we should be creating. So now Fuse is running here, and we'll go to this URL in a second. And it's creating a new container named REST container 104. Let's make sure that's the case. Refresh this. REST container 104. So we created the new application automatically, and it will then deploy the REST application to this container. And we'll see that. Well, it's taking a second here, but I think we can get environment variables. No, not yet. Okay. So once it does that, then now when it does that, and it goes to the next step and runs acceptance tests, and it passes, then what you could do is that would allow the build to continue on into QA. So okay, let's start pushing things into QA. And you could remove the entire environment that you just created, just delete those applications that we created to clean up. In this case, we're not going to delete it. I'm going to leave it up so that we can poke around it. I'll show you Fuse. So this one succeeded. And maybe in a real environment, you would keep around the last 5 builds or 10 builds or whatever and delete everything before that. But you would have some cleanup mechanism. But even if you had multiple builds running concurrently, they wouldn't collide because each will spin up their own set of containers, their own set of OpenShift applications specifically for that build. So compare that to a shared environment. How would you do that? Here's our environment variables. Here's the password that gets stored for Fuse. Now if I come over here, click on Fuse 104, this is the domain. So anyone on their internet could go to this DNS that got created for my new application. And this would take me to the Fuse console. The internet on my phone wasn't slow. Pretty slow. Here we go. Now I'm logged into the Fuse console. From this console, I can manage all the cluster of JVMs that I mentioned that Fabricate is responsible for, starting, stopping, configuring, service discovery, all that stuff. And we see our REST container 104. If I click on APIs, since this is a REST service, if I click on APIs, this will show me a catalog of all the REST services that Fuse is managing in that cluster. And you can load balance against them. You can discover them at runtime. I can create new containers. I can create a new container and say, hey, put the REST, this one that I just deployed. And maybe instead of one container, I want to create 100. Now, what that's going to do is create 100 Linux containers, install the JVMs, install the my REST profile with this one click. Well, I'm not going to do it right now, but so you can see how scaling up and managing large clusters can be done with just a couple clicks inside of OpenShift with Fuse running on top. Are there any questions? I know there's a lot of stuff that I probably just went over. Yeah, we'll go there first.
In your continuous integration pipeline, you're pushing the artifact into Nexus. If the downstream your integration patches or something breaks, what happens to the artifact? What is the artifact? Because that's not a valid artifact. That's not a working artifact that all pushing.
Well, so what happens if it goes through CI and passes? Then what ends up happening is a branch is created in GitLab or GitHub or wherever your thing is that corresponds with that source code, right? Now, what I coded in here, if that fails or it fails some other point, then it'll go back and delete. So with Jenkins, you have the ability to, if the build fails in a certain way, you have a really fine way of describing how it fails, then you can take corrective action, compensating action. Well, so no, I was saying you could remove the Git branch. From Nexus, I don't know. That's going to be a governance policy that you guys come up with. I would just leave it, but that's really just up to how you guys want to manage that. Because you don't want to change versions in place, and if versions are already in there and are being used, you don't want to remove them, right? But on the other hand, you could end up with a pile of builds that fail. So, yeah.
So you talked a little bit about the cost of change at the very beginning of the presentation, and you kind of hit on how this is hitting kind of infrastructure and developer productivity. Can you talk about, with a platform like this, what are some of the social changes that you need to influence an organization to make something?
Yeah. So this demo shows you that technology-wise, this is possible, right? But like I said, you're not going to walk into Amex or some big old financial institution and say, all right, we're going to start doing DevOps. So what that requires is, and probably the same applies for doing microservices, is how you group your teams to be based on the function it provides to the business versus a project. When I see teams at Amazon, they're not organized by here's a group, here's all the DBAs, here's all the UI experts, here's all the whatever. They're organized by here's our order processing team. UI, DBA, middleware specialist, everybody works together, operations person. They own the life cycle and they own that service from inception to production. So you don't have In that scenario, you significantly reduce. So let's take technology out of the picture for a second. You significantly reduce the coordination and the communication, cross-functional communication that you have to have with. If you had a separate database team, now we have to file a ticket for the DBA, and we have to tell them to do this. Oh well, they come back. Well, that's a shared database. You can't really do that. We have to do something different. And so then you go back and forth, and it ends up being. So if you organize yourself to align with the business functionalities that you're delivering, it'll be a little easier to adopt this sort of model. Otherwise, what we have today is really based on the old model of, hey, everything's a constrained resource, hardware, disk, software, databases, licenses, software, all this stuff is sort of, the way we organize right now is predicated on that. Whereas you introduce infrastructure as a service or platform as a service and different architectural styles, then you can take advantage of the fact that, hey, maybe those constraints aren't there anymore. So let's revisit how we organize ourselves. Does that answer your question?
So on Fabricate, you said it did deployment and versioning control, but it also did load balancing and failover. So that seems to be, that would be like me deploying part of Jenkins in my mind to my prod environment for Jenkins to do something. It seems like it's a very...
So how do you mean?
Well, I mean, Jenkins is build management and kind of continuous integration. And what you're saying, Fabricate does some of that also, but it also has like a runtime component that does load balancing and failover. And so that seems to be...
Maybe I probably didn't explain it. Fabricate has tooling to be able to push stuff in and out of Fabricate. So really what it does is a glorified Git scripts to be able to push profiles into Fabricate and pull profiles out of Fabricate, zip them up and push them into Maven. But the tooling that Fabricate specifically has isn't oriented around continuous delivery. It's really specific to Fuse or to Fabric, right? So when you deploy, so the Maven plugins and the tooling create those profiles. The profile is just a text file that says, okay, we'll deploy version A, or application A version 1. And now when I take that profile and put it and assign it to a JVM, so if I look at the REST 104 container, the my REST profile is assigned to that container. So now that container, that JVM, containers overloaded, that JVM now has my REST application running in it. Now when my REST application started up, it discovered, hey, I'm in a Fabric, I'm going to publish my endpoint. The context path, hostname, port, all that stuff. So that gets pushed up into Fabricate. Now Fabricate acts as a runtime registry then, at that point. Now your clients can come and look that stuff up.
Does this integrate into RHQ?
Not yet, but it will.
JBoss operating network is downstream of RHQ. I was curious about that kind of management.
So as of today, you can run JBoss operations network alongside your Fuse deployments. You can run it on OpenShift nodes and all that. But it's not, so what ideally I think is what's going to happen is RHQ is going to be broken down to a set of services, consumable services, and then they'll have a UI, but then we can plug those set of services into Hot.io or into the Fuse UI, and it can be, those pieces can be reused across multiple contexts, not just in JBoss operations network. Because then you'll have, because that provides monitoring, right? Fuse or Fabricate here provides management of your middleware. And when you combine those two, then you have a single pane of glass for management and monitoring. Any other questions? Yeah.
One of the problems we face is when I build my own OSGI application and then I try to install it on the Karaf console. It has dependency on, it basically needs jar files. But I'm not able to find OSGI jar files. So then I had to download the OSGI jar file wrap up in my own OSGI container, then my application is able to use it. So how do you tackle that problem of the lack of the OSGI jar files, open source jar files out on the internet?
Well, then you have a choice to make. Do you trade off the modularity that OSGI gives you and the class path isolation, all that stuff that it gives you, and just do an Uber jar? I mean, that's certainly one option. I don't see that as that's not typically an OSGI favored solution, but on the other hand, if that metadata, if those OSGI bundles don't exist, then you know, adding that to the jar, depending on what type of jar is, could break the license. So you're not really supposed to do that. And at the end of the day, as long as there's no class path collisions in that single Uber jar, that's what the people that are writing Spring Boot applications are doing. They're just jamming everything into a single class path. Or Drop Wizard, they just create a one Uber jar. Now you just have to be careful how you share, because then those individual bundles, those individual components are not reusable by other applications. Right? Does that answer your question? All right, thank you guys. Thank you for coming.